Okay, so with a proof, you have to come up with some sort of game plan. Come up with how you're going to get from the given information to whatever you're trying to prove. So we start off knowing that lines are parallel. There's a lot of information that we know based off the fact that these lines are parallel. You could go crazy. You could say that all of your alternate interior angles are congruent. All your same side interior angles are supplementary. You can say that all your corresponding angles are congruent. You can go crazy and talk about all your vertical angles. But in the end, you need to look at it and say, okay, what's going to actually help me get to my goal, get to where I'm trying to prove, and that is that angle 1 supplementary to angle 7. So please come up with a game plan. Get in the habit of that. Make sense of it to yourself. So, there's many ways to go about this. Because right now, angle 1 and angle 7, we can't classify those angles. There's no classification that we know. So we're going to have to do a little bit of work to come up with some sort of information about angles that we can classify, like corresponding, or alternate interior, or alternate exterior, or same side interior. So there's a lot of ways we can do that. We can use vertical angles. Using vertical angles, I could say that this angle is congruent to that one, and this angle is congruent to this one. Now, I've got information about these two right there. Well, those are same side interior angles. And so we could say, well, if lines are parallel, then these same side interior angles are supplementary. And then you could prove, well, if these two are supplementary, then those two have to be supplementary as well. So that's one train of thought. You could use linear pair. You can use linear pair to help you figure out that these angles are supplementary. And that's exactly the route that they have chosen. So we've got to follow whoever the author of this proof was, we have to follow their train of thought. So if we look at their statements, they start talking about angles 1 and angle 3. So if we look at the diagram, what do we know to be true about angle 1 and angle 3? They're a linear pair. So we know that these two guys are going to be supplementary because the definition of linear pair. And because they're supplementary, then we know that the measure is going to add up to be 180 degrees. Well, now we're incorporating angles 1, 3, and 7. So we need to find a relationship between all three of these angles. So we know that these two are supplementary because the definition of linear pair. We know that 1 and 7, those two are supplementary because that was given to us. The only relationship we don't know right now is what's the relationship between angle 3 and angle 7? They're corresponding angles. And so if lines are parallel, then corresponding angles are congruent. So that's the relationship that we know. Well, if angle 1, we don't know that angle 1 and 7 are supplementary. We're trying to prove that. But if these are supplementary because they're a linear pair, and I know that angle 3 is congruent to angle 7, well, angle 1, that measure's not changing. So, if the measure of angle 1 plus the measure of angle 3 equals to 180 degrees, and 1's not changing, and we know 3 is congruent to 7, then the measure of angle 1 plus measure of angle 7 is also going to have to equal 180 degrees. So that's kind of the route that they're taking. So you always begin with your given information. So I know that line A is parallel to line B because that's given information. From there, after you state that the lines are parallel, how do I know that angle 3 is congruent to angle 7? Good, so you need to make sure that your reasons are matching your statements, like the logic of your reasons. So we started off knowing that lines are parallel, so that's what your if-then statement needs to start off with. So if that's the case, then I can conclude and justify that angle 3 is congruent to angle 7. So my conclusion is going to be then corresponding angles are congruent. So I've got my hypothesis and I've got my conclusion. Right now in step B, the second step, we're trying to conclude or justify that angle 3 is congruent to angle 7. So you better make sure that your conclusion of your if-then statement matches that. Next, If I know two angles are congruent, those two objects are same size, same shape, then what allows me to make the transition into saying that their measurements, numerical values, are equal to one another? What's up, Sam? Definition of, I agree with but what's the rest of it? Congruent angles. You will never use the definition of congruence. You'll never use that as a reason. You will never use the definition of congruence. It doesn't exist. Well, not when you're dealing with proofs in this class. It's either the definition of congruent angles, that's what allows you to transition from objects are same size, same shape to measures are equal, or vice versa. You could be told that two angles have the same exact measurement, so they both have a measurement of 50 degrees. Well, then by that same definition of congruent angles, you could say that those angles are congruent. So this definition just allows you to transition in between talking about angles are same size, same shape, and then into or out of the fact that the measures are equal. And the same thing works with definition of congruent segments. Definition of congruent segments. So if you wanted to talk about those segments, their objects being the same size, same shape, you can then transition into saying that their lengths are equal by the definition of congruent segments. So make sure you know what you're talking about, either angles or segments. But you will never use definition of congruence. You'll never use that. Moving on. So there was a good train of thought going on here. We had that these lines were parallel, and then because of that, we had these angles were congruent because they're corresponding angles, and then a good train of thought. Then we started saying that the measures are equal. Then all of a sudden, way out of left field, we're talking about two different angles and something completely different, supplementary. So we're trying to say that in the fourth step, part D, that angle 1 and angle 3 are supplementary. Whenever that happens, whenever the proof seems to be going in a good general flow and all of a sudden something out of left field, it's usually one of two things. Either A, it's another given. And so this statement could be a given. Or what's happening now is that they're pulling a statement directly from the diagram. So this statement that kind of seems to kind of pop up out of nowhere, angle 1 supplemented to angle 3, we can look at our diagram and we can see that what's the relationship between angle 1 and angle 3? They're a linear pair. Okay, so this statement is strictly based off of the proof, off the diagram. So this is definition of linear pair. Definition of linear pair. Then, the measure of angle 1 plus the measure of angle 3 equals 180 degrees. What allows me to transition from talking about these objects are supplementary to their measurements summing up to be 180 degrees.
Definition of supplementary.
Definition of supplementary. Good. If you want to add angles to the end of that, that's fantastic, but I'm not going to require you to do that. You can just say definition of you can just abbreviate it, supplementary, I know what you're talking about, or you can write the full word out. And again, angles is not required, but if you put it, wonderful. From there, what's changing from E to F? What's changing in these equations? Right. Where the measure of angle 3 was, now in its place is 7, the measure of angle 7. So what allows you to plug a different value that you know is equal? That's substitution. Now, substitution is a very generic property. So it's not absolutely necessary that you write of equality, because you'll never use it dealing with congruence. There's no such thing as a substitution property of congruence. That does not exist. So when you're using substitution, and the only reason I bring this up is because some of you are coming in during tutorials and you're correcting those extra assignments and you're making quiz corrections and so on and so forth. And you've noticed that on all of my keys, I don't put substitution property of equality. And so a lot of you keep asking me, well, is that wrong? Like, did you just forget it? It's not necessary to know with substitution, but I will not count off for it. If you put substitution property of equality, I won't count off for it. But I'm just letting you know. No, my keys are not wrong. It's not necessary to deal with substitution. But it's rather you might want to be, what is that saying? Rather be safe than sorry. So go ahead and put it. It's fine. But you'll never use substitution when you're talking about congruence. And then from there, if I know that two measures add up to be 180 degrees, then how do I know that they're supplementary?
Definition of supplementary.
Definition, I don't know why I'm using a different color. Definition of supplementary. And again, you can write it out or you can just say definition of SUPP, supplementary. I know what you're talking about. And we've discussed this before where it may seem a little weird that we are stating two angles are supplementary and we're also justifying it by the definition of supplementary. It's kind of like if you're hanging out with one of your friends and you use a big word like discombobulated and your friend's like, what does that mean? Well, if you define the word with the same exact word, you're just like, oh, the definition of discombobulated. Well, it doesn't help them at all. So I know that this may seem a little weird, but we've discussed it before that if I'm trying to prove to you that some object is a unique or a special object, like these two angles are unique angles, they're supplementary, or if I want to prove that a triangle is regular, it's a special type of triangle, or if an angle is a right angle, you have to prove that based off of the definition. You have to show that that object satisfies that definition. So that's the only way to prove that that two angles are supplementary, is by proving it by the definition. If there's nothing else that you can show two angles are supplementary other than just using the definition. So that's the whole purpose, is that we were working towards showing that these two angles satisfy the definition of supplementary. That's why they are supplementary. I don't know why I keep turning this on. It's like a strobe light. Sorry. Some of you guys might have seizures. Anywho, down to the next one. If we look at this second proof, it's extremely similar. We're dealing with angles 1 and 7. They're supplementary, and then also the lines are parallel. So the difference is where it's just the exact opposite. We start off knowing that these two angles are supplementary, and now we're trying to prove that the lines are parallel. So similar, but we're just going the reverse order. And you're going to see that these proofs are very different, how we have to attack them. It's very different. It's not just going to be the above proof, just completely flipped, like inverse. It's going to be completely different. So let's talk about this. We're trying to prove that lines are parallel. You guys, whether you believe it or not, or know it or not, you know many, many, many ways of proving two lines are parallel. You could prove two lines are parallel by showing that their slopes are exactly the same, if you had some coordinates. You guys know that if you can prove that same-side interior angles are supplementary, then you show that you can prove that lines are parallel. If you show that corresponding angles are congruent, then you know lines are parallel. Or alternate interior or alternate exterior angles are congruent, then lines are parallel. So you've got a lot of arrows in your quiver to prove that lines are parallel. But again, since the statements of this proof were all given to you, you have to follow their train of thought. Because maybe some of you really like alternate exterior angles, and so you're just like, well, I want to show that angle 1 is congruent to angle 8, and if that's true, I know lines are parallel. Well, that's a reasonable way of showing lines are parallel, but that may not be what they're going after. So since we're given all the statements and we don't have free range of proving this our own unique way, we have to look at, okay, where are they going? And so, of course, they're going to start off with that these angles are supplementary, but they're going to work down towards, and they're going to work down to showing that angle 1 is congruent to angle 5. So they're going to use, if corresponding angles are congruent, then lines are parallel.